What's up, fellow Polymaths? In this video of the Java Fundamentals tutorial, we'll be going over clean coding and best practices. Clean code is code that a developer can examine and change without much difficulty. The code base is easier to maintain and troubleshoot if any problems arise in the program. The traits of clean code include being built to provide specific solutions, being as simple as possible but no more simpler, because complexity is usually not a good thing. Clean code can be thoroughly tested without issues, and clean code contains reusable methods and classes, which makes it easier on the developer not having to reinvent the wheel, as well as reducing code duplication. Regarding best practices, variables, methods, classes, interfaces, and other identifiers should have descriptive names that make sense. Essentially, these identifiers you'll be able to instantly know what it's supposed to do. These identifiers should either use camel case convention or underscore convention, ideally the former. So I'm here in the code editor, and basically what camel case means is using something like this, for example, and underscore is like this. While both are good, camel case is usually the preferred way. Of course, depending on who you work with, they might have their own purposes as well. Variable name should have a noun describing name. So when you think of nouns, you think of persons, places, or things. So a good variable name would be number of boxes, and a bad variable name would be XYZ. Method names should have a verb describing name. So you can think of like an action type of name. So a good variable name would be get total amount or throw the ball. And a bad variable name is a method name that someone that's looking for the first time wouldn't be able to know what the method is supposed to do. Class names should have a noun describing name, such as a person, place, or thing. A good method name would be something like employee, and a bad public name would be something like class 1 or class 2. Make methods small and make them do something specific. Remember that the method name should describe what the method is intended to do very easily. So you want someone that's never seen the code before to be able to know what the method is supposed to do within a few seconds. You want to have only the necessary amount of parameters that are needed. If many more parameters are required more than usual in the method, then you should consider a way to refactor that method. Ideally, methods should be no longer than the size of the screen. There's some debate in terms of how long a method should be. Some will say 30 lines, some say even more than that, some say even less. But the rule of thumb is that as long as the method is not longer than the size of the screen, then it's okay. But again, you want to make sure that methods do something specific as possible. So if it's doing a lot more than that, then you should consider refactoring that method. More on best practices. Limit the amount of comments made in the code to what is only necessary. Comments should help the developer understand the purpose of the class, as well as methods and other identifiers. A description of what the class is supposed to do at the top of the page is helpful. Avoid leaving comments across the classes unless absolutely necessary. So basically here what is being described is that you should only use comments when they are needed. So for example, if the developer wants to know what a specific class is supposed to do, you can leave a brief description of that class towards the top of the page. But if your variables and identifiers have well-defined names and your code is more clean, then it might not even be necessary to leave comments. Only leave comments unless it's extremely helpful to do so. Another best practice is to avoid hard-coded values. If the value of the variable is supposed to remain the same, mark the variable as final or make the variable an enumerator. If possible, the variable can be part of an environment variable, which utilizes a configuration file. We haven't went over environment variables much, but basically what environment variables are is that they're variables that are hard-coded, but they can be changed based on changing the file, a specific file. So you can think of them as final variables, but they won't be changed in the code. They're only changed through the configuration file. Another best practice is to unit test your code. Unit testing leads to more robust code that's less likely to break the program. This saves time when you may need to make a change to your code. JUnit is a specific tool that's used to test Java applications. Mockito is also another unit testing tool as well. We haven't went over JUnit in the Java Fundamentals tutorials, but JUnit is a good tool to use whenever you want to unit test your code. Another best practice is to avoid returning null values. You should either return an empty value, a default value, or properly handle for the null pointer exceptions. Not doing this will cause the program to throw out unintended exceptions, which can lead to undesirable results. More on best practices, classes should be well organized. Instance variables should be private, only being called by the getter and setter methods. Whatever is in the class, variables and methods should have a reason for being there, otherwise they should be removed. Remember, nothing unnecessary should be in the class. If you don't need it, then get rid of it. Classes should be small enough that they are able to do what they're intended for. Some classes are going to be much larger than others depending on the scope and requirements, but ideally they are not too large. Of course, the definition of large could be pretty broad, but good judgment comes handy here. Multiple small classes, but not more than necessary, are better than one large class. There isn't really a one-size-fits-all approach, and you can think of it like an art and a science. You have to balance the two. Classes should be a blueprint representation of the real or abstract world. As an example, an employee class would have variables such as their salary, the years with the company, as well as methods such as retrieve salary information, and so on. Remember, think real world representation or abstract representation when it comes to classes. With indentation and white spacing, you should make a new line after the end of the statement or before the column length of the class has to be scrolled just to see the whole line. Also, use a tab after having to make a new line statement within that same statement. This improves the code readability. For example, if the line gets too long when inputting a statement, you can make a new line, and then for readability, you tab it so that the next line is indented from the initial statement. This makes it a lot easier to read. Variables should be logically grouped one line right on top of each other. Variables that aren't logically grouped together should have an extra empty line spaced away. And going back to the code example, what's meant by variables that are logically grouped is that any variables that are not part of a group should be separated by an empty line. So this is an example of what I mean about variables being grouped together. We see here the first group is based around the cities and states. So the first two within the first group are integers, and then the next variables within that same group are strings. But they're all pretty much involve the same group, involving a city, state, or county or country. Then the next group right here is spaced with an empty line, involves cars. So here we have a double, integer, and string. So basically you want to group the variables based on what type they are and what their intention is. Going back to the best practices, methods and constructors should have an empty line spaced away from other methods and fields. So again, this makes code more easier to read. With logging, you should only log what's necessary and helpful to complete the work. Not everything has to be logged, and for potential security reasons should not be. So in this case, for example, if you're dealing with a production environment, you might have access to something such as personal information, or what's also called PII, personal identifiable information. It's pretty much the standard that these shouldn't be logged. Logs should clearly explain what the information is as well as the status of the log, such as an exception, informational, debugging, and so on. So tools for logging include log4j as well as a system out print line that Java comes with. Again, logging is very helpful, especially when you're trying to debug code, but you should only log what is necessary to get the job done. And again, you should not log information that's sensitive. For the class structure, the class starts out with the package, and then after the package is followed by the import statements. Then you have the top level class. Then after that is the class variables, which are the static variables. Then the instance variables, which are like the non-static variables. And then you have the constructors and the methods. With the project structure, the file should be saved in well-defined package names based on what those files are supposed to do. So the way that files should be stored is that in the source folder for your non-test Java programs, they should be stored in a main folder, and these are the source files. And then you'll have a resource folder, which you can think of as property files or configuration files. For the testing files, when you want to perform unit tests, for example, you'll have a test folder, and inside that test folder will be a Java folder that will have Java testing source files. And the same is for resource files, where you'll have resource testing files, which will have configuration files or property files and so on. So here's a quick example of the class structure. So here we have our package statement that comes first, and then import statements. I can just import something simple like a scanner class. I'm not going to do anything with this, by the way. I'm just showing an example. So here I import the import statement comes after the package statement. And then after that, we have the name of our class. Inside the curly braces, we can have things such as our static variables, such as this, for example. And then our non-static variable, which will contain an empty line after the static variable, could be a variable name without the static keyword. And then after the variables, we would have our constructor. So here I'm defining a constructor that's under the variables. And remember in the previous classes that we went through. So here, for example, we have our variables, and then after we have our constructor that's below the variables, and then after our constructor we have our methods that's below the constructors. So that's how you would define the usual class. And finally, with best practices, the most important thing of all this is to use your best judgment. When choosing between multiple best practice philosophies, stick with one throughout the program and avoid flip-flopping. If this video was of any value to you, then please leave a like, comment, share, and subscribe. Thanks for watching, and I'll see you later.